Very good morning, dear students. I'm expecting already most of the students came. Great. Sai Krishna, Prashant, Samresh, Indra, Kamlesh, Dasha, Panja, and one more is Amrita. When it is scrolling up. Very good morning, dear students. I'm expecting. So, Arpita, very good morning. So, very good morning to all of you. Shalini Kumari, very good morning. So today class, I think yesterday differential amplifiers we have completed some part. So that's why today video I kept it as differential amplifier part 2 will come. Okay. Maybe by 10 o'clock we'll reach the concept. So 10 o'clock we'll take a break the bath. We'll start a new topic today called as operational amplifiers. In operational amplifiers in your syllabus, if you see, we have to complete 3 steps now. The first step will be based on amplifier design part. The second step will be mathematical operations. Last step will be nonlinear applications. These 3 steps will cover the complete workbook. You can complete it. So today my job is not only completing the concept. We have to do the workbook simultaneously. Parallel will complete the workbook also. Okay. So shall us Ujjwal, very good morning. Anurag Giri, good morning. Shovik, Yuvik Kumari, great. Pawan Kumar, very good morning. So I think you're all well to start the class now. So today class, whatever we completed yesterday, one time I do the revision, we done AC analysis yesterday. In the AC analysis, we got 2 modes of operation. One is a differential mode, one is a common mode. So today we'll try to cover differential mode, how to find out the characteristics. That is like input impedance, output impedance, voltage gain, how to find out. In common mode also, how to do the process. That formulas are very important. Pankaj, very good morning. So let us start with journey subheading. First we'll go for a differential mode. We'll start. Differential mode. In AC analysis, we are going for differential mode of operation. In differential mode, I already told you, your VC, common mode voltage should be 0. When you are doing this mode of operation, common mode voltage should be 0. Then how the AC model you can see here is, will be seen like this. This is your transistors. We have a resistor RE. In AC analysis, we have to take ground minus VE, and we have RC here, which will be grounded. Supply should be ground. So supplies we have made it as ground. And what is the inputs for the 2 transistors is? Only we have to take here V1 as VD by 2 we have to take in differential mode. V2 we have to take it as minus VD by 2. Actually in differential mode, these are the inputs are going to the amplifier. Very good morning. So these are the inputs are going, at that time common mode is 0, we have taken. So separately we are analyzing this. Vishal, very good morning. Krishna Kumar. So this is the story today. So whenever you apply these inputs like this, differential inputs, these 2 magnitude wise they are looking same. VD by 2, magnitude wise they are same. But I think phase wise they are different. The one is having a positive phase, one is having a negative phase at the input. That is the difference coming in the differential mode. Now what I understood is, when this produces a current here, suppose this current is some IE current is coming here, AC current. This AC current is IE current, so that is also giving same current magnitude, but oppositely it is giving because it has a negative sign. It has a negative sign. This is the meaning I understood. So both are giving emitter currents for you, but one current to other current magnitude wise they are same. But current wise one is a negative current, one is a positive current because one person applied a negative voltage, one person applied a positive voltage. These 2 currents when it comes here, the overall current which is IT you can say, overall current IT is becoming IE minus IE, it will become 0. So this is the situation I am seeing in the class. Simple situation it is. Simple situation that both the currents are coming same magnitude wise, but the phase wise they are different. So automatically when these 2 currents comes to RE, they have to add each other, but they are getting cancelled and becoming 0. So in a differential mode, I think the current passing through RE will be 0 in AC analysis. Due to that reason, what I can do is, if I have the voltage here, suppose VE voltage, small VE, what is VE here is, it is IT, total current into RE. This answer is becoming 0. That means this total is becoming a short circuit here. When voltage drop is becoming 0 here, then why can't you write this model like this? Again I changed the model with this idea. Your differential mode is giving the equivalent model like this. Very interesting ideas, try to understand step by step. This is RC, this is ground, we have RC to ground. In this class what I am doing is, RE I am disappearing, only I am writing VD by 2 minus VD by 2, and I think in place of RE I kept a short circuit to ground. So this total drop I made it as 0. So we don't see capital RE in your differential mode in the class. So in the differential mode of operation, Jahnavi, Rata, very good morning. So VD by 2 minus VD by 2 whenever you do, this total drop will become 0 such that it will become a ground point. We don't see any capital RE effect in differential mode. That is most important idea. So if I take this as Q1 transistor and this as Q2 transistor, if I cut this part into 2 parts like this, symmetrical circuits there, I get into 2 halves like this. If I take only one half from this circuit, only one half I have taken. If I take only one half, how the circuit is looking, you can see. Suppose Q1 transistor if I take, this is RC and this is ground, this is VD by 2, this is your V0. This is one half circuit you are seeing. So other half if you see here, the other half, if you cut into 2 parts, they look like this. This is minus VD by 2, this is RC, this is ground. This is your V02, this is V01. So this is Q1 transistor, this is Q2. If you correctly observe, these are 2 are looking separately. If you see, they are looking like a common emitter bypass amplifiers. So finally, we are bringing the circuits into our knowledge. So finally, if you cut into 2 parts, they are looking like our first basic classes. Common emitter bypass amplifier there. So it is working like a common emitter bypass, and this is also working like a common emitter bypass. That means you are joining 2 common emitter bypass circuits in this case. So we have a good knowledge about common emitter bypass that will help us to solve the questions very easily today class. Okay. So if you can complete up to here nicely, today what I'll do is to find out my characteristics. I'll take only one transistor analysis and I'll bring to the combined structure. All the tricks will apply. See the mathematics. So up to here is very clear. I'm expecting. Please note of it. Okay. Rahman, very good morning. So today class is a very logical class. Try to understand it. Simple way of understand. Here this total drop became 0 in differential mode. First point. This RE became short. That's why it is straightforward grounded. And I just cut the transistor into the differential amplifier into 2 parts. If you cut into 2 parts, they are symmetrical circuits. Both are identical. So we have 2 common emitter bypass systems. Up to there, we completed the story. So let us understand what we have to find out. Okay. What characteristics we have to find. First we'll do the definitions. Then we'll start proceeding the calculations here, 0. We don't have any RE. It has been nullified by your current. So RE will not affect anything here. Capital RE will not affect anything in differential mode analysis. So please tell me if it is clear up to here. You just note, write down the message clear so that I can understand for the next step. I can proceed very easily. Okay. After writing this, try to understand it and write the message clear so that next step will be easy for me to proceed. Okay. When you understand, write down clear. If any doubt you have, just message me. I'll just give you the answer for that. You should not get any doubt because very clearly I explain the content here. Nothing doubt should come. Okay. If I miss anything, you must get out. I'm teaching step by step. Clear? Great. Kamlesh has said clear. That's a very good thing. Great. Yeah, show it. Pawan Kumar. Great. Done? Rema? Good. Ananya? Clear? Great. Samresh? I'm very happy that you're saying clear. It's a good thing. Yes, it's the first slide, Paul. This is the first slide. Don't worry. Just now I started the class. Anupam Das is asking, in this model, we are using dual input, balanced output. So whatever you like, you can use. Suppose if I take like this, what is the meaning of this is? It may be single input or dual input. I have taken my example previously. Dual input I have taken. Balanced output I have taken. This is called balance. Okay. An example of dual input, balanced output I am taking. So let us start thinking about next issue. Next I'm coming to the characteristics. Differential mode. Differential mode. Characteristics. Yes, we have to solve these questions today. One is the differential mode characteristics. The first point we have to solve is point number 1. Input impedance. How much will come for differential mode amplifier? Input impedance. These are the very important questions in gate exams. So have a clarity on this concept. ZIN he wants. But what is the definition of ZIN for a differential amplifier is? It is VD is your input for a differential amplifier and your IB is the input current. So this is the definition of input impedance for a differential amplifier. And second one, output impedance. We have to calculate output impedance, which is nothing but Z0, which is V0 divided by some I0. V0 by I0 we have to calculate output impedance. Concept number 3, unbalanced differential gain. So unbalanced differential gain I can solve in two variety of modes. One is V01 divided by VD. This becomes your AD1. The first transistor V01 effect we can solve. This will become one differential mode. Or we can solve AD2, that is V02 divided by VD. This is another differential mode. So we have two responses we can find. One is individually we can find out at V01. Already I told you unbalanced means any one output we have to take. Input is always VD only, but outputs can change. Okay. So one person if they ask at V01 position, you can solve that gain. That is one unbalanced gain. And he can solve at V02. That is also an unbalanced. So these are the two unbalanced gains. And coming to the fourth one, the last one, we have is balanced gain. Balanced differential gain we can solve. Differential gain. Balanced differential gain means it is nothing but overall gain, AD. You have to solve for V01 and V02. So you can take here AD1 minus AD2. You can take a difference of AD1 minus AD2 or AD2 minus AD1. So in general, we take this as in modulus. So whatever you like, you can solve. Okay? If you solve one side, you get positive answer, one side negative answer. So you keep in modulus so that it can be any answer, magnitude wise, you can tell the value. Because there is no rule that I have to take AD1 minus AD2. I can take AD2 minus AD1 also. So we have two chances. That's why this definition I'm giving in magnitude. So these four characteristics how to solve simply in the class by the knowledge called common limited bypass system analysis. With the help of these four answers, how I tackle it side by you can see. I'll take only one half analysis, but I'll teach for the full concept. I'll take just observation of one half, but I'll get the complete concept of differential amplifier. If I take only one half, it is not more than a common emitter bypass circuit. Just take an individual bypass technique. In this, I'm seeing your transistor is like this. This is ground. We have RC. This is grounded. This is your V01. I'll take first response. This is your VD by 2 input for the only one transistor. This is your Q1. I'm taking just only one half circuit to analyze, but the answer should come with these parameters. How I'll get the answers? We'll see. First, observe here. This equivalent model, if I write here, it looks like this. Simply, it will come as R pi. This is VD by 2. This current is IB current passing to it. And we have a current source, GM into V pi. And finally, we have a load, RC. This is output, V01. Writing the AC model is not a very tough. It's very easy and comfortable because a lot of time is spent for amplifiers. The only thing is R pi I have represented, current source I represented, RC I just spent it to output to get V01. This is called AC model observation for this amplifier, called common emitter bypass amplifier. Now the first question you are asking about the input impedance, how to find out. So if you see from here your input impedance for the one transistor, the input impedance for one transistor, it is VD by 2 divided by IB. This is for one transistor input impedance. It is VD by 2 by IB will be the input impedance. VD by 2 by IB is nothing but simply R pi. So this is the input impedance I got for one individual transistor amplifier, but we want combined for two transistors. So my definition is not that one. My definition is this one. VD by IB is my input impedance. Okay, that is for only one transistor. Now we want for two transistors. Then how to convert this answer? This is only for Q1 transistor. This is the input impedance of Q1. But if you want for both Q1 and Q2, the definition should be this one. We must get. So we can write this answer as simply ZIN is equal to simply we want VD by IB. You want VD by IB. Whenever I want VD by IB, these two you can take that side. So it will become simply 2 into R pi, which is nothing but for Q1 and Q2, both you will get the answer. So this is the way how I simply converted my knowledge. So only for one transistor it is R pi. Whenever you want for two transistors, it will become 2 R pi. That is the knowledge. Okay, this completes my simple calculation about input impedance for a differential amplifier when it is under differential mode of operation. So this can be represented as 2 into 1 plus beta times of simply RE. Right? This is a very interesting and golden formulas for my differential techniques. This is one important investigation. Very interesting formulas. So in exams they'll ask you, please calculate the input impedance of a differential amplifier. The answer will be 2 into 1 plus beta times of small re. Otherwise 2 into r pi you can write. Because r pi is nothing but 1 plus beta times of re in RE model. So this completes the beautiness of my input impedance calculation. So now how to calculate output impedance? Output impedance is very simple, I'm expecting. That is not a matter to solve. Output impedance is not a matter to solve here because it's a straightforward analysis. If you want to solve output impedance, you're solving here, Z0. Z0 is nothing but simply RC is the output impedance. So one thing you have to remember, whenever you are solving for output impedance, you said that only solve for one transistor. Because the load we cannot take for both transistors, load will be taken only one side. It may be left side or right side. So the load will not change. RC is the answer for it. But input impedance, we want for the combined two transistors, not for the one transistor. So it is a load we should not take for two transistors, we have to take only for one transistor. Any one side you have to take the load position. So that's why R0, Z0 became RC directly. But the ZI became 2 into 1 plus beta times of small r. Okay. Pawan Kumar, in previous class, why we have taken only one side means to teach that on the other side what is happening. Both sides you have R pi, but we want to distribute the comparison. One side is capital RE, one side is that R pi. I want to know which side the current will go. In that manner I got for you. Generally we have both sides R pi. Okay. So both sides will have R pi. But for study purpose, where you want, there we indicated the R pi. So that is a small concept Shabani with Pawan Kumar. There is a meaning here. Okay. You want to compare RE, capital RE with respect to R pi. So other side I have written it. Shabani Das is asking Jadayan how it comes from two transistors. Simple logic here. If you see the yesterday class story, just can you visualize it? Yesterday class story. This is your transistor, my friend, and it is being connected with another transistor. Shabani Das, try to concentrate in this idea. This is your R pi. Here R pi will be there, and here also we have R pi, and here we have open because the IP current cannot go this side, I said, because it has a very high resistance. This is the story we have listened. So IP is going from here to here. When IP is going from R pi to R pi, then the overall impedance from here to here will be 2 R pi or not. So that is the basic calculation we have done. It is VD by IP. It is not VD by 2 by IP because VD by 2 is only for one transistor. But we want for two transistors the input impedance. Means the impedance not only completed here, the base current will go to here also. So it is going to touch the two resistances here in series. R pi plus R pi. That's why it becomes 2 R pi in electronics. Okay. I think now it is clear. Samresh, here first time teaching for unbalanced. Okay. Unbalanced, balanced को differentiate करूँगा in single amplifier. Okay. Don't get worried about that. So this is the meaning here. R pi plus R pi will become 2 R pi. That's why ये definition understand करो. VD by IP you have to solve. So that is the meanings first I explain for you without confusion. So the trick applied. For one transistor is R pi, then two transistors will be 2 R pi. And the output impedance always will be calculated only for one side. So output impedance will be calculated only one side. So output impedance will be calculated only one side. Not two sides will calculate. So one side if you calculate, it will be RC. So only one side you have to calculate the output impedance. So these are the two beautiful things we can cover in the class. Next we want to know unbalanced gains how much. The first answer is asking 81. Unbalanced gains I am solving. Unbalanced gains. The first gain I will solve from this diagram. If you see the gain of here, it is A. First we will solve the ratio of this transistor is V01 by VD by 2. For one transistor, this is the definition. V01 divided by VD by 2. Your input will be VD by 2, output will be V01. The gain formula we know, it will be minus GM into RC. This is called as balancer, or I can say bypass gain in electronics, minus GM into RC. So but here he defined. Rahman, output impedance will not change here. Anytime your output impedance will be RC is the load. Because if you keep a differential amplifier like this, suppose, here I started my signal, this side will become your load. This is your load, this side you have to take. That side will be always RC will be the load. Both sides you should not take. Only one side you have to take is telling. Samresh, Shabani Das, who you here? If your amplifier is like this, I'm giving input one side. Inputs are going like this. But on the other side you have the load. The load will come from any one transistor. So we cannot take in the middle the loads. Load will be taken only one side. That's why the answer will be RC is telling. So this is the unbalanced gain, minus GM into RC. But he is not asking V01 by VD by 2. He is asking for a differential input is VD, not VD by 2. Just convert this answer now. Your AD1 is expecting to V01 by VD he want. So always remember one thing. The input for a differential amplifier is not VD by 2. It is only VD. But we are doing for our convenience VD by 2 first. Then I am converting into my answer. For convenience I am doing like this. First I am completing my subtopic. And then coming to my answer. This 2 will go that side. So it will be minus GM into RC by 2. This is the answer you are expecting. So AD1, just this 2 is extra here. V01 by VD by 2. So we will get half value. This can also be represented as AD1 value in the class. This is the formula for AD1. AD1 is completed. So how much simple the answers are coming from previous classes you can see. This is AD1. If I want AD2, it should be opposite sign will come for you. AD2. We'll take another action. Here only I'll complete. So the second calculation is V02. Suppose if I take V02, but if I consider this transistor is Q2 transistor, my input will be simply minus VD by 2. This is my second input. First input is VD by 2. Second transistor input is minus VD by 2. That gain also becomes minus GM into RC. This is the Q2 transistor gain. This is Q1 gain. This is Q2 gain. So already already you are having some negative input here, previous one, Q2 transistor input minus VD by 2. So this minus, if you see, negative sign will become positive. So AD2 if you want, the answer is V02 by VD if you want, the answer. Just by 2 is coming here also, but negative will become positive here. So we are getting here plus GM into RC by 2. So that means one gain is coming negative gain, one gain is coming positive gain. So this is the story of your unbalanced gains in electronics. If you know unbalanced gains, then what is the balanced gain? If you want a balanced gain here, it's a balanced gain. Just to take the modulus and solve it. Modulus of AD is the difference between two gains. AD1 minus AD2. Just to take the modulus and solve the difference between these two gains. That's the confusion in higher classes. Differential amplifier means input is always equal to VD. Oh, mind me first. That is the reason first definitions explained. Okay, I am doing my derivations. Okay, because if you take only VD by 2, you are considering only one side. But gains we want for the total 2 transistors. If you want for the total 2 transistors, the VD will become the input, not VD by 2. First we are solving with VD by 2 from our basic knowledge. Then I am converting into the formula called VD effect. So this formula is very important. First the meaning understand. Why SR is converting like that. Okay. If you write VD by 2, you are considering only for one transistor. That will not become differential amplifier. For any differential amplifier, both the inputs should be considered. Both the transistors should be considered. That is called VD effect you have to take. That's why nicely first I am representing that. So the student may not get confusion. Okay. So what is the last answer is? It is a modulus of minus GM into RC divided by 2 minus GM into RC divided by 2. So minus you can leave it off. So answer will be simply GM into RC in modulus you can give. This is your balanced gain in the class. If you see the balanced gain, it is just looking like our common emitter gain. It is just looking like our common emitter gain. So these are the basic formulas which will help us to solve questions based on differential amplifiers. How smoothly the formulas you can see I completed in the class. Only student has to believe that. He has to believe that the input for a differential amplifier is not VD by 2. It should be VD, difference between the two inputs. That is the input for it. That's why whenever you start this class, first you study these definitions. Whatever I have written first is the names you study. Everywhere you can say VD is the input I am taking. But when I am teaching the derivations, only for one transistor I am solving it, I am converting it into two transistor methodology, the formula. That is a simple trick I have learned. So please clear up this topic. The major topic is completed. This is the concept called differential mode, how to find out the input impedance, how to find out the output impedance, how to find out the differential gains. One is unbalanced, I know. One is balanced, I know the formulas. These formulas are very easy to remember and recollect. GM into RC is a formula for balance, which we already know. It's a common emitter gain. But when you talk about unbalanced, you take it as half of gains. That means if the balanced gain in a differential amplifier is 1000, suppose, who will take unbalanced means only one side, you will get the gain as only 500. That means you will lose the gain whenever you take unbalanced applications. That is the meaning he is telling. Unbalanced will give always half of the gain of balanced gains. If you want more gain, balanced is better than unbalanced. This is the meaning you can understand. So beautifully complete up to here. Concept is ready. Lastly, one more special issue now called as common mode how to analyze. That is the next issue. Kumar, here AD1 and AD2 are the unbalanced gain with respect to both the transistors, not both the one transistor. That's why I have written here the formula of VD. VD, whenever you write, the meaning is SR is considering both the transistors, but only one output I am taking from the two transistors. Okay? Always consider both the transistors. Don't consider only one transistor for this analysis. Imagine that. What is that? Other transistor, N will be minus. So whenever you talk input impedance, common sense use karo, only one side se baat karna, input impedance. One side only you have to talk. From here you are saying for the second transistor, so 2R pi. If you want the other side, you have to talk from there, that is also 2R pi. Input impedance is never be calculated on both sides. Only one side we calculate, where one place I am getting 2R pi there, and the other side also we get 2R pi. Any side you see, it is 2R pi. So input impedance, output impedance have the same story. We have to calculate only from one side. Okay? Input impedance also, we have to calculate from one side. This also will be calculated. Input impedance will be calculated only one side. This is the application meaning. Both sides you should not calculate because it's a symmetrical circuit. Okay? Any one side you have to calculate the input and output impedances. Yes, Shabanidas, AD1 is for two transistors, AD2 is also for two transistors, but we are taking unbalanced output there. Okay? Unbalanced we are taking, but input we are taking from both the transistors. That is called VD. So please complete this. We'll go for common mode calculations. These formulas are very valuable formulas, so don't forget these formulas, simple formulas. Input impedance is 2R pi. Okay, that's easy to remember. Output impedance is load RC, and gains are very easy. GM into RC is the balanced gain, and unbalanced gain will be GM into RC by 2 will be the unbalanced gain. So formulas wise they are easy. Nothing much pain will come when you practice these formulas. So let me clear off your mind whether it's clear or not. I've given all the doubts clearance. Say that it is clear so that we'll go for common mode calculations finally. There is a main issue now. Examiner can ask you common mode gains and he can ask you these gains. So let us understand what is the difference between common mode calculations. Differential mode is clear, I'm expecting. AD1 and AD2 are concerned to both the transistors. Here AD1 and AD2 are concerned for both the transistors, Q1 and Q2. And AD is already concerned for both the transistors, Q1 and Q2. Always you have to consider for both the transistors, the analysis. Okay? All these formulas are related to both the transistors. Great. Everybody understood, it's very clear. Great. So I think the typical topics we are completing very nicely. This completes my first lecture, called as differential mode analysis is completed. Great. Rahman, today confusion is one here. For one circuit it is only R pi. But if you consider for both, the formula has been changed. 2 has gone there. VD by IB for two transistors, it became 2 R pi. खत्म हो गया ना यार. Formula से क्यों इतनी बार पूछ रहे हो point? Already clear of pick up previous example में 1 R pi, the base current is going to second R pi. So the impedance will be in series with 2 R pi. becoming 0. Then how the model looks for A is, this is your differential amplifier. Carefully see the concept. We have RE, this is ground, and we have RC, this is ground. Again we have RC2, ground. DC wise it is 0, but what happened here? Both the transistors were giving common mode. Common mode is nothing but my inputs will be same. This V1 equal to VC, V2 is also equal to VC. Both will go same input. Previously in differential mode, one input is going positive, one input is going negative. But in common mode, both the inputs will be same. Why sir? What is VC meaning? I said in the previous class is, your VC is nothing but common mode voltage. Common mode voltage. What I defined in the previous class it is the average of the two signals is common mode. Common mode is nothing but average of the two signals he has taken. Okay? That is called common mode. So common mode will be the same for signals is common mode. Common mode is nothing but average of the two signals he has taken. Okay? That is called common mode. So common mode will be the same for both the sides. So both the sides, the answer is V1 plus V2 by 2. Can I say that the current coming from here will be IE, small IE current? The same current will come here, small I. Here what happened is, these two currents are getting added at RE in the class. So in differential mode, this RE is playing a role in the concept, where I total will become 2 times of IE current here. So this is the difference coming between a differential mode and a common mode. Okay? In common mode, RE is not becoming 0, but in differential mode, RE is becoming 0 in the class. In differential mode, RE is becoming 0. They're short. We don't get short here because both the inputs have the same magnitude. So how to write this model? How to show this model in another manner? You can see. This is 2 RE I am writing. This is RC. This is VC. This is V01. And second transistor will be 2 RE. This will be VC. RC2 ground. This is V02. So if you see the trick here, if I cut this block again into 2 halves like this, I split it into 2 halves. When I cut this RE into 2 parts, it became 2 RE in the class. Why? Because if 2 RE, if you take parallel again, if you join these 2 points, suppose, this point and this point, suppose you have joined like this. If you join like this, these 2 are parallel. So 2 RE, if you take parallel, this answer will become RE. That is the trick we have applied. So each transistor, we are getting some emitter resistance in differential amplifier. When you divide it into 2 half parts, it will become 2 RE and 2 RE resistance in the RE point. So, okay. Yashwant, why we call this as unbalanced gain? Yashwant, unbalanced gains, why we call 81, 82 means because we are taking only particular output for one transistor. V01 is a one transistor output. That's why it's called unbalanced. Okay. Balance means for both the outputs, if we take V01 and V02, then we'll call it as balance. These are the things yesterday nicely explained for you in the class. So 2 RE is being divided into 2 halves. Now cut this part into 2 halves now. I cut into 2 halves like this. Therefore, you can have separately this circuit. But how this is looking is looking like common emitter unbypass. So in common mode analysis, the amplifier is looking like a common emitter unbypass circuits. So now the style is unbypass circuits are coming in the class. Where RE plays, we have to write 2 RE for the 2 transistors. So we'll take simply one transistor to finish the subject. Unnecessarily we are increasing our mind. The concept is simple only. We are making tough by thinking more and more. Rahman is telling that only. So overthinking. Yes, overthinking that the confusion will come. If you think smoothly what the sir is telling, if you can understand the point clearly, then there is no doubt actually. Because we are not teaching, without basics I am not teaching. Each point with the basics I am explaining that point. So common emitter unbypass. The RE, why it is divided also you can see. 2 RE, if you take joint, it should become RE. So this is Q1 transistor and this is Q2 transistor. If you write only for common emitter unbypass, if you take any one analysis, I'll take in the next page, you just take it like this. If I cut this point into 2 halves, okay, just you can make a break point here, otherwise just you can make break like this. 2 RE, QRA, you can show like this. So up to here, you finish off. Let us do the calculation part. If I want these characteristics, first point, input impedance, the differential equilibrium. So VC divided by IB is the definition. So ZN means just a VC by IB you have to calculate. Here there is no problem because only one input impedance if you can solve, I think your answer is completed. Previously it is not completed because VD by 2 there. Here VC only. You're talking one side, VC by IB if you can solve, you'll get the input impedance in common mode. Here problem nahi aapko. But previously it is VD, here it is VC. So that's why this answer you have to finish off. Seeing the board, you can tell the answer, which we have studied in our BJT classes. What is the answer? Seeing the board is simply, it is R pi plus the style of writing. You will have an R pi here plus 1 plus beta times into 2 RE. So this is the backup knowledge we have from common emitter unbypass techniques. So the input impedance you can see, previous answer is 2 R pi, that is for differential mode. But common mode is giving the answer R pi plus 1 plus beta times of 2 RE. Now you can think which input impedance is more, differential mode or a common mode. The input impedance which we got previously is VD by IB, which we got it as 2 into R pi. So you can see both the answers. One is a common mode input impedance, one is a differential mode input impedance. I can say that this is giving low input impedance. This is giving low input impedance, but this is giving high input impedance. So in the exam if they ask you, common mode will give high input impedance or a differential mode means it's a default common mode will give high input impedance because we have a common emitter unbypass system in the class. Whenever you have a common emitter unbypass, we'll have high input impedance because of the factor 1 plus beta times. Okay, that completed my first step. Majendar, unnecessarily आप confused हो जाते हैं यार. इधर clearly दिखाना यार. These two are connected to emitter points. We have to join it or not. Then if I write here RE by 2, suppose according to your knowledge, then if you take parallel, it will become RE by 4. आपको क्या चाहिए इधर? RE चाहिए. RE चाहिए तो क्या लेना? 2 RE if you take parallel combination. Okay, 2K parallel to 2K will become 1K or not? क्यों ऐसे confused हो जाते हैं समझ में नहीं आता मेरे को. Okay, बोर्ड में इतने clearly दिखा रहा हूँ concept 2 RE लेना यार. I said you are telling there RE by 2. क्या करना then मैं? अब ज़्यादा confused होते क्या होते हैं? ये exam में you do more and more mistakes. So confusions थोड़ा avoid करके first concentration on the concept type into it. Okay. Otherwise, throughout your life, that will become a hobby for you always. Unnecessary confusions will create in your mind. Some 10% students will be always confused by themselves. Okay, unnecessary confusion. Smoothly, what the sir is teaching here. 2 RE, 2 RE, sir bol rahe ho. Okay, parallel combination le rahe. Then it will be RE, satisfied. Next, I'll go to the next point. Unnecessarily, you are going in bypass concept. Your mind is going in bypass manner that RE by 2 क्यों नहीं ले रहा हूँ? ऐसे think भी नहीं करना. Okay, you don't think in extra things. Sir बोल रहे हो RE parallel to RE, 2 RE parallel to 2 RE. It will become RE. Complete हो गया job. Unnecessarily complications कर रहे हो आप. Shabin is asking, Jaren is 2R by किधर से आया? अरे previous topic से आया ना यार. अभी किया ना. What is the question यार? समझ में नहीं आता मेरे को. ये क्या है? 2R by वो आंसर उधर लेकर कंपेयर कर रहा हूँ यार. Differential mode and common mode का comparison कर रहा हूँ. I'm doing comparison बेटा. This is the answer. This is the answer. We have two answers here. This answer is for common mode. We got. This is for common mode here. This is for common mode. And this is for differential mode. Previous का result लेकर compare कर. Differential mode. One is for common mode का impedance इतनी आया हमको. Differential mode. Examiner if they ask you for which impedance it is high, you should have a visualization. It is a common emitter unbypassed system, sir. That's why it will have high input impedance. If the differential mode is working under RE zero effect, that means bypass system, sir. It will have low impedance. Okay, that is a nice approach. Then what is the output impedance if you see from the board? Output impedance will be always equals to RC. We don't have any trouble with the output impedance because output always taken from one side of your load. It may be here, it is RC. It may be here, it is RC. So output there is no change. It may be common mode you take, or you may take differential mode. The answer will be same. So इनमें टेंशन नहीं है आपको. Input impedance थोड़ा change होगा. Output impedance में फर्क नहीं पड़ रहा है. Only input impedance में थोड़ा changes आ रहा है. Okay? Because of bypass and unbypass systems, it will change. What about the gain? How to find out for this problem? The last point, gain calculation. I'll complete here only. That's it. Smoothly I'll cover the gain aspect. If you want to gain, see here, point number 3. Unbalanced gain I'm finding. Unbalanced common mode gain. Common mode gain. Which is equal to AC. AC unbalanced gain. We are finding. AC unbalanced gain. AC unbalanced gain is, you can write in the brackets, unbalanced. AC unbalanced. The formula is, you can take any one gain, it is V01 divided by Vc suppose. Only one side gain I have taken. Okay? But here for two transistors it is valid because both sides have the same input. So both side input is Vc only. Vc is Vc only, but Vc1 is one side output we have taken. So if you want to, I think V01 by Vc, if you can solve for one transistor, come हो जाएगा उधर, unbalanced gain आ जाएगा. Directly ये transistor answer लिख दीजिए. So the answer will be, it's unbypassed formula. So minus Gm into Rc divided by 1 plus Gm into 2 times of Re. So smoothly I completed the common mode unbalanced gain in the class. Unbalanced gain formula is already studied so many times in Actiloads I studied, in our common emitter amplifier I studied, so it became a hobby I'm expecting from the students. It is minus Gm into Rc divided by 1 plus Gm into Re, but Re became here 2R. Just substitute it there 2 Re. Okay, so if I just make Gm into 2 times of Re, suppose this answer is much greater than 1. If I take like this for simplification, Gm into 2 Re is a very high quantity which is much greater than 1, then automatically AC unbalanced, the gain can be written as simply Rc divided by 2 times of capital Re. So can you see that here Gm factor has gone in the class? There is no Gm here because Gm will get cancelled. So the answer is minus Rc, minus will be there, minus Rc by 2 times of Re is coming in the concept. Minus Rc divided by 2 times of Rc. So this is for Q1 suppose. This is for Q1. But if I want for Q2 suppose, AC unbalanced. For Q2 transistor also, we are getting same answer. Minus Rc by 2 Re. This is for Q2 transistor. Can you see in this topic, I think both are giving similar answer because it's a symmetrical circuit with symmetrical input. If you have both inputs are same, I think your unbalanced gains will be same. You take for Q1 same answer, Q2 also same answer. Okay? If both have the same answer, what about the balanced gain, balanced common mode gain will be? So last answer. What is the balanced common mode gain? Fourth point. Point number 4. Balance common mode gain. Common mode gain. Balanced common mode gain. Here AC balance. The answer will become 0. So this is the story of balanced gain. So we are not getting any balanced gain because both are symmetrical circuits. If you take the balance between two transistors, the output will be, gain will be 0. So we don't get any balanced gain in the calculation, but unbalanced we can solve it. So these are the beautiful things a person should understand in our analog electronics. When you go to VLSI designs, these are the most important calculation parts. The student should have the ability of understanding these issues when you are upgrading your knowledge in your integrated design part. This is about the set of my input impedance knowledge. This is the set of output impedance knowledge, and this is the formulas which we have got for unbalanced gains. This unbalanced gain formulas, and balanced gain is 0 ultimately in the class. So this completes my total issue about the class. Concept is ready. Partha, that is a combined analysis we have taken previous class. Okay, common mode plus a differential mode completely when analyzed. RE is open I have taken and I started my thinking first. After that, when you cover the differential mode and common mode separately, one has an impact of I0, one does not have an impact of I0. So RE becomes 0 in differential mode. We got common mode when you do separately, RE is not equal to 0. We got. But if we take combinedly, RE will be there. Okay, RE we have taken high resistance and we made it as open. The only reason here you can see and if you see the input impedance is coming very high in common mode. That means we are assuming that it is a common mode analysis. We just opened it because of very high impedance and we are teaching the concept. Okay, so RE effect we have removed in the class here. But when you do separately the classes, take the RE effect and understand the picturization. One is not having, one is having with the analysis. Previously, it's just imagination that base current when it is entering. I said that for base current, the RE effect is very high. I just opened it and I studied my class initial to get the formulas. Basic knowledge, V1, V2 कैसे लिखना उनके लिए develop किया. After that, you go for these techniques. differential mode, how to apply, common mode, how to. In general, RE will be high in the class. Okay? RE will be always high resistance. So have this good knowledge. So one of the good and great knowledge I can say in case of differential techniques. So these two issues has taken 1 hour time, no problem, but we got the main content in the class. Remaining topics are easy, they will not take much time to study. So balance gains, unbalanced gains, recollect the formulas, all the things you see in your notes. Differential gains means Dimag Verabo. We have used common emitter bypass techniques. Okay, common mode means we have applied common emitter and bypass techniques to get the answers. So in common mode, RE effects will come. Everywhere you will see capital R is here. RE effect will come in common mode analysis. RE effect will be nullified in a differential mode analysis. That is the beautiness in the mathematics we are seeing now. So please cover it. Just we'll come to the final topics now. Hardly 4 topics are there. Each topic may take 10 minutes to understand. 10 to 15 minutes maximum to understand each concept now. The next job we have is CMRR, how to measure. That is the final next concept. We got common mode knowledge, we got differential mode, so we can find CMRR he's telling. So let us understand how to measure CMRR. That is easy now to teach the class. CMRR, how to measure. So if it is clear, please tell me so that I'll proceed for the next step. Just 2 minutes, can finish off. I think your doubt is clear there. RE, why it is coming in this lecture means both the inputs are having same magnitude. So that IE current when it passes, IE current going, AC current is going to the RE effect is not 0. That's why RE is considered in AC analysis for common mode analysis. As a differential mode, we'll make it as RE into IE. IE becomes 0, so short circuit. That's the way you have to separately study the both the analysis. But we are doing overall analysis at that time. RE you can neglect it and we can study it. But separately when you study, you have to consider one place. In one place we are not considering it. So can I move to the next step? Is it clear? Students, make it highlight these formulas. And be ready for the next topic. Just I'll take some water. So let us move to the next step. Okay, I'm expecting everybody has completed. Everybody is completed? Some internet issue is there, just 1 minute. I'll keep hotspot. Otherwise I cannot see your messages. Daily here some internet problem is coming. So I'm using my hotspot daily. Just 2 minutes. I'm just arranging my hotspot to connect laptop. Yeah, it's connected. Great. So Srebnidas and some other student who is asking me that RE is open. RE is open. Why I have done one more time? I'm giving explanation for you. That is Barbara, they also asked the same question. Whenever you are doing some analysis that inside what is happening at that time RE is open, so that we got 2 modes of operation from that differential mode and common mode. After getting that knowledge, we applied again differential mode separately and we applied common mode separately and we understood how the RE effect will be in the circuit. Okay. First analysis, how to get both the modes inside we understood by assuming that RE is infinite. Okay. That is the difference is coming. That's why you are getting confused. Samarish, RE is high because of not reverse bias Dimag Verabo here. RE is reverse bias Kiraboloamide. RE is a resistor, becomes very high because 1 plus beta times of RB as the base current is entering to that. The other side we have is R pi. Like that beautifully I taught the class. Go back and see the concepts. Go back and see that. Okay. So with this, we'll close this matter. We'll come to the final topics. Quickly we'll complete the concepts. Now after covering 4 topics, my 5th topic is CMRR. One more interesting measurement called CMRR. CMRR is nothing but common mode, rejection ratio. Actually in op-amps, operational amplifiers, differential mode is wanted. We want this. This is wanted. But common mode, whatever the characteristics you got is unwanted. So these are the difference actually. We are not interested on common, we are interested on difference because differential amplifier in the name itself, we have to give 2 separate inputs, not the common input. So common input is unwanted for us, we want only differential amplifier. So differential mode is important. So, but in this amplifier, we are getting both, common mode is also coming, differential mode is also coming. So we have to separate it. differential I want, common mode I don't want. So you have to reject the common mode. So unwanted thing I want to reject. So the op-amp, how much the differential amplifier, how much it is rejecting the common mode. If I want to know, it has a definition of AD by AC is the definition. So CMRR is measuring with this ratio. AD by AC is measuring in the concept. AD by AC. Okay. Now the point is, theoretically if you want, how much is the answer? Practically if you want, how much is the answer? Suppose if I want theoretical answer, how to solve this? CMRR. If you want theoretical value, we can solve as AD, you can take balance. AD you can take balance, or AD you can take unbalance. Anything is okay. Anything you can take, but divided by, theoretically if you want, the AC should be only balance you have to take. So if anybody is asking theoretical value, you measure with the balance in the denominator. You take AD balance or AD unbalance is your wish, but AC you don't take it unbalanced, you take it as balance. Then you get a theoretical or ideal answer for it. So what this answer is? AD balance, AD balance or AD unbalance, AD unbalance divided by, it is AC unbalance is 0 we got in the class. So 0 is our balance again in our calculation we got, correct? So whenever AC balance is 0, this answer is coming to be infinite. So this is the behavior of CMRR, which is an ideal CMRR. How you got CMRR ideal value means this is the way how you got. Numerator can be anything you can take, balance or unbalanced, but denominator don't take it as unbalanced, take it as balance. Then you get an ideal value or a theoretical value in electronics. So this is called, you can say ideal value. This is called ideal. CMRR is infinite. But sir, practically how to measure it? Go for practical knowledge now. So CMRR, again practical way of writing the answer. It is AD balance you take, first answer, divided by AC unbalance you take. You can measure two ways. So we can measure AD balance by AC unbalance, and second step I'll do this one, AD unbalance by AC unbalance. So we have to take denominator, unbalance is important. So AD balance formula, we got it as minus GM into RC, this is the formula, divided by, we got it as minus, leave it off because we are talking magnitude, GM into RC divided by RC divided by 2 times of RE, this is called unbalance again we got, AC unbalance. So can we write this answer as RC is cancelled, so it is 2 times of GM times of RE. So this is the CMRR. CMRR for what means? For balanced systems we calculated. For balanced systems. So anybody ask you for balanced system, what is the answer? You have to tell 2 into GM into RE. Why got the name balance means? We have calculated for balanced gains. Denominator is unbalanced we have to keep to get the practical answer. But numerator you have to take balance. So answer is 2 into GM into RE. Suppose if I take another answer, CMRR is equal to AD unbalanced I am taking. Now you can measure unbalanced system also by AC unbalanced you can measure. So AD unbalance divided by AC unbalance. AC unbalance. Just 1 minute. 10 o'clock. Wait. CMRR AD unbalance divided by AC unbalance we are telling. Okay. So shall we calculate this answer also? It is GM into RC by 2. We got unbalanced again. Half of the gain is unbalanced divided by RC by 2 times of RE. So RC will be cancelled. Your 2 will be cancelled. So it is GM into RE. So these systems we call it as unbalanced systems. So in the exams they can ask you balanced system, what is the CMRR? Unbalanced system, the only difference is balanced system it is 2 into GM into RE. It is unbalanced system, it is GM into RE. Will be the answer for it. Yeah, breakfast करना थोड़ा 10 o'clock तक wait करना. So 10 o'clock I'll give the break because this module has to complete today. 10 o'clock half an hour to wait कर. Okay, by 10 o'clock we'll complete differential amplifiers. Happily you can take breakfast 10 to 10:30. 10:30 से our game will start on op-amp designs. Okay, that is the story. So give me half an hour to finish the remaining topics. So complete this. You can see one topic takes only 10 minutes now because they're all things we covered. So it is a beautiness to complete the task. Easily we can complete it. So ideally, at ideal we take AC balance. Somebody says वही बोल रहा हूँ यार. If it is an ideal one, AC balance लिया मैं. If it's a practical one, I have taken. This is called practical approach. This is called practical thinking. For practical, you take unbalance. For practical case, you take unbalance. Because you'll get some results here. Practically, you'll get results by AC unbalance. If you take AC balance, you will not get any result. That infinite will come. So that's why one is an ideal way of thinking, one is a practical way of thinking. So AC balance we have to take for ideal case. Okay? And practical case, we have 2 different systems. Balance we can do it, unbalance we can do it. Denominator should be unbalanced only we have to take. Okay? This is the way how he is going to measure the differential amplifier, how much is the ability to reject the common mode. Okay, common mode का कितना reject कर सकते हैं. That measurement we call it as CMRR. If you say clearly, if you want CMRR more and more, common mode rejection has to increase more and more. Nothing is there. This capital RE should be very, very high. That only is asking. Yesterday in the previous class we have seen RE is infinite. We have taken assumption. As RE we have to take very high so that the CMRR will approach towards infinite so that the common mode rejections will be good for you. Okay, common mode will not enter into the op-amps. You get only signal conditions there. That is called differential signal analysis only will happen. So with this we have been finished with the topic CMRR concept. The next 3 techniques are there today to finish. One is swamping technique. Next topic is swamping technique. So each topic will take hardly 10 minutes, don't worry, to finish this. And workbook is there. Workbook separately, I'm not recording for this. Here only we'll complete workbook also. Hardly around 5 questions are there in easy book. So I'll follow easy book for op-amps complete chapter, which are relatively same for electrical book. Okay, relatively same. That's why you just complete any one book. Okay, I'll concentrate easy book in op-amps. So you can see the next point. If you complete up to here, CMRR, the next concept is sixth one, swamping resistor technique. Swamping resistor So why should I use this technique? I'll show you now, which is some RE dash. We are giving some RE dash extra here. In your differential amplifier, for extra RE dash I'm giving, see the model, how it is going to change. So this is your model. We have some RE dash I'm adding here, which is called our swamping resistor, newly added. And again we have here RE dash. Bottom side we have already RE, the negative battery. This is your V1, this is your V2, and we have RC, and we have RC. This is your supply VCC. So what is the importance of keeping two resistors at the emitter point? So why we are keeping that? I'll tell you the trouble now. Why we are keeping these resistors newly? Previously it is a short here, only RE is there, now we have 3 REs. Why should I take extra like this? H1 to Sabu, the main importance or significance of CMRR will tell that how much common mode is entering into the differential amplifier, how much it is rejecting. That is called significance of CMRR. Each circuit can reject, suppose some circuit can reject 60% common mode, some circuit can reject 90%. That efficiency will be measured by CMRRs. If you have 90% rejection, the circuit is better than 60% rejection circuit. So it will tell the ability how much this circuit is working well. Okay, that is a meaning called CMRR. रहमान आपका क्वेश्चन समझ में नहीं आ रहा है मेरे को, अब क्या बोल रहे समझ में नहीं आ रहा है. Reject common mode for same input or gain 0. What is that question statement? वो statement ही समझ में नहीं आ रहा है मेरे को. So here, suppose if I take this as your output, it's a dual input balance output I have taken. Now suppose in this model, if I ask you if RE dash is 0, if RE dash is 0 in the class, that means there is no swamping resistor in the class. If there is no swamping resistor, if I ask you what is the input impedance, we got the answer as, in differential mode I'm talking, we got the answer as Zn is equal to 2 into 1 plus beta times of RE. So this is the answer you got. 2 into R pi is the answer. Okay, and we consider that this is a low input impedance. Low input impedance. This is one problem we have. It's a low input impedance is coming. And second point is, point number 2, your AD, you take anything, AD balance, if I take suppose, AD balance, your answer is GM into RC. But GM into RC can be written as RC divided by small re. GM can also be written as 1 by RE we can write. This formula, if you see correctly, it is RC by VT divided by your ICQ. If you write correctly this answer once again, it is RC by T by into ICQ into 11,600. If you correctly observe, your gain AD. Your gain AD is actually depending on temperature that I understood. So can I say that first of all, the gain high or low is not important for any amplifier. Stability is more important for the gain. If the gain is not stable, you cannot get my voice like this. So first important issue is not a gain high or low. Stability is very important. So I have been understood. Temperature wise it is depending. So temperature changes, AD is changing. So it is called unstable. It is a gain is unstable. So these are the two problems I'm facing. Low input impedance is not good for ideal amplifier because a high input impedance is better. I said loading effect we can solve. If you have low input impedance, we get loading effect. Loading effect they'll create in your amplifiers. So one is loading effect problem is coming. Another one is unstable problem is coming. Because of these two problems, what I have done in the class is simply here we have R pi, here we have RE dash. So we can have here a joint. Here there is a R pi, and here we have some R pi. So what is the trick I have used in the class is this is R pi, this is RE dash. Suppose here I am expecting base current is not going, emitter current is going. I am talking about emitter current. For emitter current it is RE dash, but R pi is not for emitter current. So for R pi you have to write RE. So what is the change here we are getting is it is RE plus RE dash. It is replacing the concept. So wherever you have RE in your formulas, that is getting just making the formula overlap by RE plus RE dash because they will get in series. You should not write R pi plus RE dash. When you write RE dash here, you write here small RE. Okay, emitter resistance you have to convert it. So if you see in all the formulas, in these two formulas, there is RE here. This is creating problem, and here also we have some RE. This is creating problem. This is not creating problem for your amplifier. One is making unstable, and one is making your concept. Or you can say low input impedance is coming. Then what is my trick is swamping resistor trick applied. If I not take RE dash is not equal to 0, which is called swamping technique. Your RE will change to RE plus RE dash in the amplifier model. This is called swamping technique. So wherever RE is there, just replace it with RE plus RE dash. Okay. So if you have any confusion, you can write this as small RE. This is small RE because emitter current wise you are teaching. When you talk about emitter current wise, RE plus RE dash you can write. So RE plus RE dash will make my first answer input impedance is 2 into 1 plus beta times into RE plus RE dash. So can you see that it became high input impedance? You get mega ohms of impedance, and it's solved loading effect. Loading effect. So the swamping resistor technique main importance is to create high input impedance for your op amps. So without swamping resistor, there will be no op amp design in electronics. So the swamping main purpose is to boost up your input impedance. Already you have basic amplifier impedance is only 2 R pi, which is in kilo ohms. Just I made the addition of RE dash, which is in kilo ohms, so that it will go to mega ohms because of 1 plus beta times. Okay? Because of the factor 1 plus beta times, that value will go to mega ohms. This is one advantage from this technique. So swamping technique is very important. What is the meaning of swamping? The word itself is telling, if you have a low resistance, I just swamp it with high resistance. Yes, I added it. When I add what happens, low resistance importance will be gone, high resistance importance will come. This is called swamping in the class. Okay, just I swamp with the resistor. And coming to the second one, your AD we have is RC by RE, but RE becomes here RE plus RE dash. RE plus RE dash. There is a change in the swamping technique. So small RE, capital RE, if you see, your RE dash is much greater than small RE. Your RE dash is in kilo ohms, small RE is in ohms. So RE can be neglected. So your AD formula becomes only RC by RE dash. Can you see that your temperature problem has been solved? Your RE has been disappeared, so no temperature effect. So it became stable. So this is the beautiness of my next one important technique in op amps. So main purpose of using this one is swamping technique is to increase the input impedance of your differential amplifier and to make the stability of the voltage gain. This is the main purpose why I use this technique in op amps as a differential techniques. So this concludes my my next issue. See how the questions will be. Rahman, why common mode is rejected means वही बोल रहा हूँ हमारे inputs for a differential amplifier is not common inputs. We are give differential inputs because we made a circuit in such a manner. It's a symmetrical circuit. A symmetrical circuit never accepts the common inputs. It will accept only the differential inputs. That's why common mode became the unwanted. I've written neatly in the notes. It is unwanted, and your wanted is your differential signal. So we are expecting the differential signal has to go. Common mode has to reject. But 100% we cannot reject because they are not ideal circuits. We are thinking that they will reject because of symmetrical nature. But symmetrical nature never exists in electronics. Q1, Q2 cannot be identical in our practical situations. Due to that, some common mode can enter into your signal and it can disturb your signal. Understood? That is the meaning here. Rahman? I'm expecting this explanation is okay for you, Rahman? So common mode is unwanted for us. Okay, differential mode is wanted. That is the knowledge of this concept. So please complete. We have only two issues remaining in the class. One is called what is that? Last two topics. One more technique I'll tell you called current mirror technique. Why should I use current mirrors here? That point I'll explain. Why should I take current mirrors? Next concept is current mirrors. We have to use. Two more techniques are remaining. One is current mirror, one is active load. Will be the final touch. Common mode means, now words please remember, it is unwanted things. It's called common mode for us. Wanted is differential, unwanted is common mode. ऐसे समझ में आकर स्टार्ट करो कॉन्सेप्ट्स को. सबनीदास RE is equal to RE plus RE dash कैसे हो गया? इसे नहीं बात करना यार. इधर इक्विवेलेंट मॉडल देखते समझ में आना. This is RE plus RE dash. RE is a word for emitter current. So whenever there is RE you're writing, you just add it with RE dash in series in the models. No need of doing this derivations again and again. Okay, if you do derivations again, you will think that you don't have brain. Okay, just you write the trick like this. Here also, if you have confusion, you just change this model to small RE. Because whenever you want for IA current change, you can write small RE. If you want base current change, you can write R pi. If you want for emitter current, you can write small RE. So because we are talking here RE dash, so here RE, so they are getting in series. I want to tell you RE plus RE dash. Why second case gain is stable? So Pandit here, what happened? You can see RC by RE plus RE dash. This RE has been disappeared because of low resistance with high resistance. We neglected small RE. Small RE is only the parameter depends on temperature. For temperature gone, RE dash is a capital resistor which will be not depending on temperatures. RC is a fixed resistor, they are not depending. So if two resistors are fixed resistors, if they don't depend on temperature, I can say it's stable in electronics. Okay, that's the meaning of what I'm telling. Last explanation once again that you said to Rahman. Samresh, क्या कर रहे यार Samresh? Last explanation चाहिए. रहमान को क्या बोला मैं? What I said to Rahman? What is it? मैं भूल गया. Arpita, I think message is visible. Last explanation once again that you said to Rahman. What is it here? I forget actually what I said. Because here so many concepts are going on. Okay, at the instant when I'm teaching, at the time please listen it. Otherwise recording video में okay after the class एक बार सुनो. Okay वो point आ जाएगा. Again repeat बोलते हैं मेरे को भूल जाता हूँ मैं. Yeah, about CMRR okay. CMRR के बारे में I have got I think CMRR is nothing but common mode you हो, differential mode you हो. Samresh, differential mode, common mode two things will be there. दोनों आ जाएगा differential amplifier में. The two transistors are identical you said, so common signals will reject because identical system में common mode will be zero and differential mode will enter into the output. That is called the concept. But two transistors you said identical, but in nature they will not be identical because of mismatch between two transistors. Some common mode slowly will enter into the output. That unwanted thing CMRR में common mode हमको नहीं चाहिए, it will come to the output. That we have to reject it. For that how much you are rejecting will be measured by CMRR. Okay, that's the unwanted thing is common mode I said. Yeah, common mode is unwanted. That I said to the Rahman. Yeah, Kamlesh, great. So with this we have finished the technique of swapping techniques. How to increase the input impedance, okay? How to increase the input impedance and how to make this concept. So stabilizers, don't get worried about these techniques. If anybody want R pi to write, it should be IB current. Whenever you want for RE effect, because in the board में देखो, मेरे को RE effect के लिए चाहिए problem. Then RE के लिए क्या लिखना इधर IE current. So you can convert whatever you want. If you want for RE knowledge in the formula, just RE के लिए IE current लिखो, okay? If it is IB current, it is R pi. Whatever you want, you can interchange whenever you want. Here RE के लिए चाहिए, उनके लिए RE के लिए दिखा रहा हूँ. Why we can say that CMRR measures the ability of the circuit. Yeah, it is telling about the ability of the circuit, how much the noise is getting rejected. Noise means you can say common mode is a noise for you. Okay? You can take it as a noise. Okay, I think this GM into RC, the formula, this GM into RC किधर से आया means previous topic जाते हैं आपको समझ में आता है. इधर formulas लिखा ना concepts. This is for differential, this is for common mode. The first topic when I came, this is my class. So this is called differential mode unbalanced gains, and this is called balanced gain. ये formula लिया मैं. GM into RC, that formula I have taken. Unbalanced का balanced का कोई भी एक formula लिया मैं. Okay? So you can go back and see your notes, you'll understand it. So this is about my technique called swapping technique. So let us move to the final issue. Last two topics are remaining. Seventh topic I'm teaching. Seventh topic, point number 7. Let us finish both at a time now. Concepts. Why can't you take two separate topics? One is current mirror. One is current mirror. I'll teach both at a time now. Current mirror and one more we have is active load technique. Both techniques I'm teaching at a time. One is current mirror, why should I use? One is active load, why should I use? Two techniques I'm using. You can see the complete design, how it will change. Differential amplifier in IC designs. Here we have V1. We have some swapping resistor, RE dash. Next we have RE dash again. Every time RE dash will be there in differential amplifier. This is your, up to here we completed. Now what is the problem coming here is, this is RE. What is the problem here is, this resistor is also in kiloohms, this resistor is also in kiloohms. So that the base current, I assume that it will go this side. but it is going this side also. When the base current goes here, when the base current AC current goes to RE, I think it is creating problem there called a DC current is there. Actually in previous class, here some operating current we have fixed. So AC is mixing with the DC there, operating current. So that operating current can disturb here. So operating current, whenever it is going there, that whatever the signal you are passing, AC signal, should not go to capital RE. That is our target. But these two resistors are looking same now. So that is a technical problem. So if you keep some resistance here, he is telling that this resistance make it very very high. If you make this as very very high, then this current, base current will bypass to this side. It will not go to capital RE. Capital RE make operating currents are there. Operating current should be constant. We want. We don't want any AC signal to mix with the DC currents. Okay. Yeah. So that's why this resistor has to become a concept of high resistance. That's why the scientist said that don't keep RE then, because we cannot make more than 10K resistor. Why can't you create here? Why can't you create here one current source inside? If I have an ideal current source, suppose, if I keep an ideal current source here, it will have some resistance parallel to that. Will be your RE will become infinite. So because ideal current sources will have infinite resistances. So that means we need a current source there. But ideally we cannot provide. Practically we can provide a current source which will have high resistance there. So if I want to create like this, what I can do in the class is, why can't you make a current mirror concept here? What is current mirror concept is, just I'll take here a transistor as a load, your transistor with a negative battery, minus VE. I will bias this by a current mirror technique. I'll take a current mirror having resistor R, this is ground. You have seen in your workbooks like this the questions. A negative battery is a negative battery only, is a current mirror, which we studied simple current mirror. Because of this current mirror, you can have a current source, will generate, you get a current source. So this is the importance of current mirrors, which we have used previously in the classes. In place of capital RE resistance, we are interested to convert the resistor like a current source. Because in networks course we have been understood an ideal current source can give infinite impedance. Because we need infinite impedance there to reject the common mode signals well. So common mode rejection करने के लिए either we need a constant DC current चाहिए और current source में AC current should not enter into that path. Therefore, if it is a practical resistance, maybe you can get here your capital RE will become here your R0. Accurate concept right? RE becomes R0. Typically this answer you can go up to 1 mega. Suppose this resistor, if I take it as 1K, this has 1K, I think I get very far away your resistance. So that whatever the current is going here, the base current, maybe it will go to this side only. The base current, AC current cannot go to this side. It will go to this side, means common mode rejection is going on here. Okay, rejection is going well. So next we have is, this is V2. This is current mirror concept. To make high resistance here, we use a current mirror technique. And top side, we have another problem. What is another problem here is, the gain we got as minus GM into RC in the first class. But when I use ramping resistor technique, it became minus GM into RC in RE. RC by RE is coming. RC by RE dash. RE dash is 1K, RC is also 1K, then gain will be 1. So gain has been drastically fallen because you want stability. If you want more stability, the gain will decrease automatically. If you want stability also, you want gain also now. If you want gain, what I can do is, I can have some active load technique. I'll create some active load here by using a current mirror technique again. This is not NPN. Here we have to go for PNP transistors. We'll go for PNP transistors. Here the best is PNP is better. This is VCC. Okay. Here PNP transistor. When you take short, you can take this side now because base 2 collector you have to take short. This is also a current mirror I have taken. So this point is collector point. If I want to find some output resistance from here, which is Rx. From collector point, what is Rx? Is nothing but simply the resistance offered by this will be R0, which will become 1 mega, which is the replacement of RC resistance. So I have seen that your load has been increased to a very high value by the technique of active load techniques. So whatever we studied subtopics that are all used in this lecture. So one is meant for to reject your AC current to flow here. I have used the current mirror technique. And here to increase my load impedance, very very high output impedance, I have used the active load technique once again. So let's see the importance I'll write side by. First point is current mirror technique is used to improve CMRR. Current mirror technique we have used it to improve the CMRR. Common mode rejection ratio. What is the meaning of that is? CMRR actually the formula is AD by AC. Correct? AD by AC. But actually AC formula we have is, which is unbalanced formula we have seen is, unbalanced formula is RC by 2 times of capital RE. This is the formula we have seen. This RE became R0 in the class now. So when RC becomes 2 times of R0, I think drastically it has increased your RE value. So AC has been decreased. Who will reduce AC content? Common mode gain if you reduce, automatically CMRR is inversely proportional to 1 by AC. If AC decreases, CMRR will increase. So this is one way of what I can say effect I have made in the class. Who will take RE very very high, CMRR will increase because AC will decrease. Because AC is inversely proportional to RE. If RE को increase कर सकते हो, then what I can say common mode का gain will decrease such that your CMRR will increase. Common mode rejection will increase. That is the importance of CMRR. That is the importance of current mirror. So active load. Next one is active load technique. Active load technique is used to improve a differential gain, AD and CMRR. Both it can increase. Active load techniques are also used to increase the differential gain AD and CMRR. So how it is going to increase differential gain? You can see how it is going to increase AD here. What is the formula we have seen is previously AD became RC by RE is the first formula. When RE dash is 0 here at the time. But when RE dash is there, the formula became RC by RE plus RE dash. This became when RE dash is not equal to 0. Sorry, RE dash is 0 here. RE dash is 0. RE dash not equal to 0. This is the way how the gains changed previously. One is without stamping, one is with stamping. When with stamping comes, the formula has been, this RE is neglected, it became RC by RE dash. This is the formula we got. Because of this denominator is increased, denominator has been increased, your gain has decreased. AD has decreased because of this effect. Now when I use active load technique, what happened is, your AD formula became R0 by RE dash. This is by active load technique. active load resistance is very high, 1 mega ohm. So as the R naught increases, active load resistance increases, your AD will increase. So you have decreased it by stamping technique, I have increased it by active load technique. So I think again the gain became high. But CMRR, if you see, is proportional to AD also. If AD is high, CMRR is also high. So this is an explanation for you side by to tell why this statement I am speaking in the class. So in exams they'll ask you why we use active loads in differential amplifiers means you have to underline these points. To increase the differential gain and CMRR, we are doing this. And why use current mirror concept? Current mirrors, why you are using means to improve the CMRR. So these are the basic things, so how they improve the concept of CMRRs, okay, AD values, AC how we decrease, all these things came from this analysis. So finally, what is my final conclusion on this topic is, this part we call now onwards in differential amplifier, we call this part as active load we are giving, and integrated electronics we are giving like this. This is active load to give some performance of AD and CMRR, and here one current mirror we have used to improve the CMRR. So this is called current mirror technique. So current mirror we are using in the bottom, and active load we are using in the top. But both looks two current mirrors, one is PNP current mirror, one is NPN current mirror. So PNP current mirror will come in the top, okay, in op-amps designs. Your NPN will come in the bottom. This is the complete package design, how they prepared differential amplifier IC, okay. Right, if you want to do that with capacitors, we don't believe that capacitors will be in IC designs. In ICs, you know that the package, whatever you get a package, is very small ICs. In the capacitors, we never feel in electronics. That's why we don't see any capacitors in amplifiers, in integrated electronics. If resistors are there, open arm transistors take सकते हैं. Resistors also will take more space, where I can keep more number of transistors in that package. That's why most of the things we'll see transistors. We don't see much resistors in integrated designs. That is the main reason why I never use capacitors and inductors in integrated designs. You can see all the transistors on. Only 1 or 2 resistors will be there in integrated ICs. Okay? Because size is very important here. Oh yeah, Divya Das AC questions, don't ask here. 1 mega ohm resistor, it will take a lot of space or not. And the resistor value increases, the size also will increase there. Okay, you are talking about integrated. Up op amp lab mein dekha, you can keep that op amp IC in your pocket. That means in that op amp there are so many transistors like this. That means what? Space is a concern for us. So that is the main reason. 1 mega ohm resistor I have never kept in my class. I have gone for transistor techniques. Okay, this is the superior techniques how they applied. That is the main reason nowadays all the devices are becoming compressed in electronics because of these beautiful ideas. I hope you understood now. Yeah. Sneha Kumari, in the first line it is RE dash is 0, second line it is RE dash is not equal to 0. Sorry, it is not RE, it is RE dash. RE dash is not equal to 0. So with this friends, I have been completed the total concept. Okay, in the workbook we have 5 questions related to that I will cover in the next module called op amps. Whenever I teach op amps, I have to start the workbook there we'll cover in the workbook itself. Not here, we'll cover in op amp chapter only. First chapter complete only, but some group of questions are there. That questions when I start, there we cover the differential problems also at the time only. Okay, separately we don't want to do that 4 to 5 questions are there, we don't want to make a separate video for that. We'll do in the next chapter after completion of the analysis. So now it is the right time to stop here differential amplifiers. 10:30 we are going to start our game on op amps. Operational amplifier is going to start. Nearly 4:30 or 5 today, our target, we have to complete the first lecture called design part called amplifier designs. Is our today class. Today if we complete the complete design part, tomorrow we'll do the workbook practice. Morning session, I'll start with the workbook practice. After completion, after the break, we'll start the next module called mathematical operations. Is tomorrow class. Okay. Today class is most important class because amplifier designs, maximum questions will come from this module. Amplifier designs. They're one of the easiest module also. You must get the grip on the basics of op amp. That I'll cover first, then I'll go to the design part. Okay. Let us take a break. The range of RE dash can be 1K to 10K. You can take. RE dash range will be 1K to 10K. It's just like an emitter resistance. You cannot take more than 1K to 10K. RE dash range. RE is also same range, 1K to